Okay, here we have to do a proof of congruence. So we need to remember how can we prove triangles are congruent? Well, if we have three sides the same, then we're okay. If we have side, angle, side, we're okay. If we have angle, side, angle, we're okay. Or if we have a right angle, hypotenuse, and a side, we're okay. The ones where we're not okay is if you just have an angle, 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 that does not imply their congruence. Angle, side, side does not imply their congruence. I think angle, angle, side does also not imply their congruence. I think that's the ones. But so these are the key four that we need to be aware of. Okay, so what one should we use in this case? Well, a good plan is just to sort of look at the triangles and start piecing together what's going on. So I would first of all notice that these two are the radius and write down that AO equals BO, and just give a little reason, both radii, probably both are radii. That's good. Okay, next. They both share OC. So AOC shared by both. And then one other thing I can write down is that this is a right angle. Angle CAO equals angle CBO equals 90 degrees. This is a circle theorem because a tangent meets radius at 90 degrees. And that's enough really for me to use this fourth one by RHS because I've got the hypotenuse, I've got another side, and I've got a right angle. The triangles are congruent. There we go. Now there are other ways of doing it. You could, there is another circle theorem that says that tangents here will be the same length. And actually you can prove it like using Pythagoras' theorem, and then you could use side, side, side. I think you could, you could work out another angle, potentially, like you could say, that you could argue that some of the other angles are equal and use some of the other ones. I think that's probably getting a bit more complex. I'd say RHS is probably the one that jumps out, but side, side, side you might use instead, and you could use some of the other ones as well.